Hi, everyone. My name is Dinah Chan Morgan, and welcome to the next deeplearning.ai event. I bring together all things AI community for everyone, and today we are very lucky to have a workshop with some special speakers from Weights and Biases. In this workshop, we're going to dive into how we can effectively evaluate LLM systems with a particular focus on Retrieval Augmented Generation, also known as RAG systems. We'll start by discussing the eyeballing technique and why Weights and Biases prompts stands out as the first great tool in this area. Next, we'll move on to supervised evaluation, highlighting why it's worth considering and pointing out some limitations. To wrap things up, we'll also take a look at how LLMs can be used to evaluate themselves, from generating their own evaluation datasets to using standard metrics and even evaluating retrieval systems. Lastly, we'll also touch on how Weights and Biases sweeps, an excellent tool for hyperparameter optimization, can be utilized to find the ideal balance to maximize accuracy and minimize costs. The session today will end with a Q&A with the presenters. So make sure to answer some or ask some questions in the chat. We'll be presenting a link that you'll be able to vote on all the questions. This workshop is also based off the foundational learnings of Deep Learning's course on evaluating and debugging LLMs, built in collaboration with the Weights and Biases teams. Everything covered in the workshop is presented as continued education from the course, and we will be dropping the link in the chat. I want to introduce our first speaker, Carrie Phelps. Hey, Carrie. Carrie is a founding product manager at the Weights and Biases teams. She studied computer science at Stanford and also went on to found Carta Healthcare before joining Weights and Biases. Our next speaker, sorry. Do you want to say something, Carrie?
I just want to say thank you, Diana. Excited to be here.
Absolutely. Our next speaker is Ayush. Ayush is also part of the Weights and Biases team as a machine learning engineer and Google developer expert in machine learning and TensorFlow. He's interested in everything computer vision and representation learning. And for the past 7 months, he's been working with all things LLMs and RLHF. Hey, Ayush.
Hello.
Perfect. And our last speaker for today is Morgan McGuire. Morgan leads the growth ML team and is an ML engineer at Weights and Biases. He has a background in NLP and previously worked at Facebook on the safety team where he helped classify and flag potentially high severity content for removal. We're so excited to have them here today. So without further ado, let's definitely get started. So Carrie, take it away.
Awesome. Thanks, Diana. So I'll zoom out for a moment and talk about the larger product vision of Weights and Biases and where we're coming from, and then we'll get into more of the details with Ayush and Morgan. So what are our tools for iterating and experimenting on machine learning? At a high level, we have a platform across models, which is building your own models, training from scratch. Prompts, which is iterating on LLMs, looking at the trace viewer, which is the focus of the course, as well as monitoring LLMs in production. And then we have our platform components, so shared tools across the system. And let's talk about models for a moment. So we started with experiment tracking. OpenAI had this problem where they wanted to see if, as they trained models over time, they were doing better or worse. And it ended up being kind of frustrating to track those metrics in one place. So we built an experiment tracking tool. Then they needed to be able to visualize how different data sets compared. And so we got into this data visualization field, and then a collaboration tool. So being able to share those insights centrally, and that's where reports came in. And finally, we need the central system of record for different teams across the organization. So how can everyone working on a project see the results in one place? And critically, and Morgan has been deeply involved in this work, is integrating and making WMB accessible across the different tools available to someone working on a model. So we started out, TensorFlow was the really hot thing back in 2018, and PyTorch was kind of the new kid on the scene. And it was clear to us that building integrations with something like PyTorch or PyTorch Lightning would make WMB more accessible to, say, the academic audience training models. And so this is a critical area of focus for us, is how can WMB play really nicely with the other tools in the ecosystem? We also integrate with whatever infrastructure folks are using. So say you're a student just getting into machine learning and you're training on a GPU under your desk or even your laptop itself, we can track there. Say you're using the OpenAI API for iterating on a prompt. We can track the results there. Wherever it is that you're doing your machine learning work, your prompt engineering, our goal is to make it really simple to capture those results. So let's talk about prompts, which is the focus of our discussion here. So first, with traces, we have a core tool to understand and debug what's happening during the process of taking an input and producing an output. And the thing that's interesting here is it's not as straightforward as you might imagine. You don't just ask someone a question and directly get an answer. There are steps like, for example, using a tool like a calculator to go calculate an answer and then incorporate that into the result that the LLM produces. And so this debugging can be really complicated, right? Especially if you're trying to look at it on, a terminal output. It's hard to parse everything that's going on. So this visual trace timeline gives you a way to understand the process, what's happening as you're interacting with the LLM. And you can also drill into your model's architecture so you can see what the steps are that it's doing. And then under the hood, you can see even more detail, the metadata that we're capturing, and each of the inputs and outputs that you've fed into the system and received. So the goal with prompts at a high level, and this trace tool in particular, is making it really easy to iterate on the prompts that you're writing and get a better result from the LLMs that you're working with. And so that's really the focus of the course. But I also want to talk about another exciting thing that we're developing here, and that's monitoring. So what happens once you have an LLM that you're monitoring in production? Well, there's a lot of people involved here, and the few problems that we see across our different customers we're working with is that it's hard to systematically evaluate what poor performance looks like. So say I have a chatbot helping my customers, and I've built this LLM to answer their questions. It's hard to really evaluate if they give it a thumbs down, if that's because the answer was wrong or because they don't like the answer, like maybe I can't change my flight. So it's hard to systematically evaluate, is it doing a good job? Is it providing the answer that the user wants to hear, but it's actually incorrect? So this is a real challenge for monitoring LLMs in production. We've also got high inference costs. So it's an expensive process, and it's hard to run traditional patterns like what we've seen in traditional machine learning. It's also there's this really fresh set of tools that people are using, and so it's really hard to just make one decision, like write the prompt once and then leave it and stop iterating. It's really important to be able to keep tweaking as you get more information about how users are interacting with your system. And it's also really hard to capture and combine data from different points of feedback in your LLM system. And so we've tried to address each of these key points with our production monitoring tools. So being able to explore within the context of the results that you've logged in WMB via evaluation boards, being able to monitor in real time and see the cost of the work that you're doing, being able to integrate with other tools in the WMB ecosystem and beyond, and then streaming those results in live so that you can react quickly. And what that looks like is something like sort of a Datadog dashboard, right? But for LLMs in particular. And so this observability tool is this new component of our prompts platform that we're really excited to have now in private preview. And so this is the next step beyond iterating on your prompts and experimenting with what would work well, is monitoring the performance of those models in production. And we'll get into more of the details of what's interesting in our LLM tooling here with Ayush up next. So I'm excited to pass it over to Ayush.
Yeah, thank you, Carrie. Hello, I'm Ayush, and I'm a machine learning engineer here at Weights and Biases. I'm really excited for this talk, and I think I have good amount of content to cover. So if something is not clear, please feel free to drop in the comment, and I will try to answer that or clarify that, as well as feel free to reach out to me after this talk, and then I can try to answer that question as well. Having said that, all those who are joining from India, are very happy Independence Day to all of you. And now let's get into the presentation. Okay, so in the past 1.5 years, we have been interacting. Okay, let me see if this is working or not. So yeah. It's wrong. Yeah. In the past 1.5 years, the way we are interacting with our world is kind of quickly changing, right? We envision interacting with the software, and that's changing. The way we interact with the tools, that's changing. For instance, as developers, we have relied on Stack Overflow for over a decade now, right? It was heavily used for finding code snippets and solutions to bugs. We either got a working answer because someone already asked for it on Stack Overflow, or we post it on the site and wait for a response. But over the past 1.5 years, SO has lost around 35% of its traffic. And ChatGPT is considered to be a huge reason for the downfall of Stack Overflow. It was reported in March of 2023, I guess, that Stack Overflow alone lost 14% of its traffic. And I mean, the reason is that a lot of developers have started asking questions directly to ChatGPT, and there's no significant wait time, right? And you can literally kind of pair program with ChatGPT. You can throw in the execution error code back to ChatGPT, and maybe it can try to resolve the code for you, right? It's a more natural way of development. And so is GitHub Copilot, right? It was launched back in October of 2021, and you see the decline of Stack Overflow right after that. For GitHub Copilot, we also have like VS Code extensions. So the place where you're writing your code, exactly at the same place, you can do code completion and fancy stuffs. And that's a great way of development. And thus, the point is that the way we are interacting with our tools and the way we are developing software has changed over the past 1.5 years, right? So the question is then, what was Stack Overflow's response? Well, they released their own generative AI-powered Overflow AI tool. With this tool, you can ask questions like, you can ask questions as well as ask follow-up questions in a conversational style like we are used to do in ChatGPT. The answers are summarized with citations, and that, I mean, you can use that to draft your question and later post on Stack Overflow as well. So just like Copilot, they also have their own Visual Studio plugin. So now you can pair programs using this tool. The point is, businesses, companies, institutions, etc., they have all started leveraging generative AI capabilities into their own product and services. Awesome. To give a few more examples, Khan Academy released their Canmingo tutor bot. Then there's Notion AI, and then Zapier also released some Gen AI power interfaces. Great. And I mean, the number is just increasing. There's like 250 plus generative AI startups that has been mapped as of August, if I remember correctly, August 8th. But again, like it's this whole field is exploding. Now, the reason this is happening is because it has been powered by things like GPT-2, GPT-4, Palm-2, Falcon, Llama 2, Claude models, etc. Right? These are all transformer-based architectures which has been scaled to billions of parameters and trained with billions and trillions of tokens at this point, with like really large context lengths as well. The focus of this talk is on on large language models, but do remember that large image generation models are also playing a role in this landslide shift that we are seeing. Right. Personally, and also everyone at Weights and Biases to be very genuinely proud of our contribution to this whole shift, because almost every major lab and companies in this space is kind of using Weights and Biases in some form, using Weights and Biases to track experiments, do model versioning and whatnot. And we are instrumented, to be honest, in almost every LLM fine-tuning workflow that you can find out there. If there's not any, we are working hard to make sure that we can provide that capabilities to those repositories and workflows as well. So why scaling billion of parameters is a thing? Well, the LLMs are powerful because with scale, they are literally getting better on tasks for which they are trained on, as well as they're unlocking new abilities. So you train a large language model for, say, language understanding or summarization, but it turns out that it can do some common sense reasoning, it can do some arithmetic, can answer some physics-based questions, which is like literally unlocking new abilities. However, under the hood or under the blanket, it's just nest token prediction, right? You provide some prior token or some prior text to those large language models, and what they do is, if you're like creating a summary or if you're doing translation, whatever, you're giving some prior text, and based on that prior text is generating the next token based on some probability distribution, right? Special focus on the term prior test right now, because that has it has adapted into its own whole field right now, and it's like formally called prompts, right? Prompts like involve instructions and context passed to language model to achieve desired task. Say in a text, we can specify the instruction, we can pass in the context, we can give in some input data or even some few short examples, right? And we can then have an output indicator and just throw in this text to a sequence model or a large language, in this case, a large language model, and it will just generate the next sequence or next token, right? Based on the prior that we have given. And yeah, like because of that, the whole prompt engineering field has evolved, and a lot of prompting techniques has been developed over the past few months. For example, and to be honest, like all these prompting techniques are somewhat unlocking even newer capabilities of these large language models that we didn't think was possible. For example, chain of thought or tree of thought. These are like really interesting ways of interacting with an LLM or making LLM do things. And the beauty is that you're just specifying think step by step in your prompt, and then model starts thinking step by step. It's really magical that way, right? So, I mean, we talked about language models, we talked about prompting, but to be honest, everything that we are saying right now is kind of possible if we have really flexible frameworks which can encapsulate all these prompting techniques. And like, to be honest, a prompting technique might be released a week back, and we need to access those techniques, right? And these frameworks like LangChain and Llama Index has made it really easy to do so. They have access to data connectors, off-the-shelf chains. We can do memory management using these frameworks as well. So the point is, with these frameworks, it has become really easy to build AI-powered solutions right now. Back in 2019, Gartner research, if I remember correctly, said that only 15% of all the AI solutions deployed in 2022 is going to be successful. I'm not sure about the percentage, but I'm sure that it's really easy now to build such AI-powered products, because you don't have to kind of start from scratch and go through the whole ML lifecycle for your particular use case. You can leverage large vision models or large language models for that. So like, yeah, if you want to build your own QA internal document bot, you might find a LangChain prompt or a Llama Index prompt template out there. So hurrah. So, I mean, the point is, we have this powerful tool. Let's go ahead and solve every problem under the sky. But that's not going to happen. And why is that? Because LLMs are a great primitive, but we're still not sure if it can do everything. If it can solve all the problems. And the biggest challenge is if we can actually properly test the LLM-based systems that we want to build for our use cases. And this brings to the main topic of today, evaluation. And going forward, I will just be talking about evaluation. Yeah, if you have any question, feel free to drop in, and yeah, I can take a look at that as well, or maybe at the end of the presentation. Now, before I go in some depth about how we can evaluate these LLM-based systems, for those who are new to evaluation, we first need to understand the difference between the traditional evaluation and LLM system-based evaluation. So in traditional ML, and to be honest, this ML that I'm talking about is what we used to do a few months back. Now, LLM has taken over everything. I mean, there are still a lot of folks out there doing proper deep learning, but yeah, by traditional, I just mean proper, like doing classification, doing like object detection, those stuffs. So in a traditional setting, we have a training distribution, right, from which we split two sets, the train set and the validation set. Then we train our model on the train set and get some metric. So in this case, accuracy of say 90%, right? We also evaluate the model on the validation set. We don't use the validation set to train the model. We just evaluate the model on that. And by doing so, we can basically estimate if the model is overfitting or if it's underfitting, right? We then evaluate on the test set, which hopefully is coming from the production distribution. This evaluation then gives us a domain shift. So what was the shift in the training and the production distribution? And then if we are satisfied with the performance of the model on the test set, we deploy it and evaluate on the production data to get a drift. Right? It's like pretty standard stuff. But while we are building LLM-based system, we literally don't have access to the training distribution. We might know which data set was used to train the model, but it's kind of hard. We don't exactly know what data was thrown into GPT-4 to train it, right? So most of the time, and most of the folks will not even care about that. And because we are mostly making API calls at this point, right? So, and the models that were trained were not trained for your particular use case. So there's no alignment of those LLMs with your production distribution. So these are two big issues that we have in LLM system evaluation today, right? So before I go ahead, I just want to make a quick distinction between building LLMs and building LLM-powered applications. So if you're building LLM, so if you plan to build GPT-5 or Llama 4 or Llama 3, you can still use traditional evaluations. It's still a very active area of research wherein we are trying to build better benchmarks. But if you're building LLM-based applications, we have to be thoughtful about it. You have to come up with like interesting solutions for your particular use case. Whatever I'm going to talk in this presentation, it might not even cater to your use case. So you have to come up with your solution, your own ingenuity about this evaluation strategies. Right. So how do we think about evaluating an LLM-based system? So I was inspired by Josh Tobin's talk that he gave a few weeks back, and I created this 2x2 chart with data, with the evaluation data on the y-axis and the metric on the x-axis. So the evaluation data will need to be correlated with your use case. That makes sense, right? And the data that you want to evaluate on should also be close to your production distribution. So, I mean, when you're evaluating your LLM-based system, you have that control, but you have to be really thoughtful about how you're gonna create those data sets. Right, so one thing, and this is maybe probably the first thing you might wanna try out is pick up a LLM that's performing really well on public benchmarks. So if an LLM is performing good on public benchmark, it might perform good on your use case as well. But there's a caveat. If your use case is like medical heavy or it's like legal documents, those stuffs, you might want to be thoughtful about what public benchmark you are using to pick that model, right? The model might not be performing great on that public benchmark, but might not have much intuition about legal documents or like your medical use cases. And I mean, to solve that problem, we have fine tuning. That's like a whole separate thing at this point, which I'm not going to touch upon. But this is where you should start, right? So if you pick a model based on the public benchmark, then the next this is not the next recommended way, but this is like one of the most extreme and the recommended way of evaluating your pipeline, wherein you hire annotators to build gold standard eval set for each component of the pipeline. So your pipeline might have like document parsing with different chunk sizes, might have a retrieval, etc. And you need to evaluate every component. So hire annotators to create data set for that, right? I mean, you can imagine that it's both time consuming and it's also very expensive. right? So if you have like a business or a startup and you have some user base already, a dedicated user base who's interacting with your product, you can then do some sort of user testing. You can do some sort of A/B testing with a LLM-based logic that's serving your product and custom, heuristical-based logic that you were using previously. So you can do those user testing and make incremental changes and see how that's working. Again, it's time taking. It might be expensive if like there's some incentive that you need to provide to the users. So it depends on your use case, to be honest. But if you do so, it's going to be really correlated with your use case, and it's also going to be really it's also going to mimic the production distribution really well, because literally your users. Somewhere in the fuzzy area is the idea of like a crazy idea of using large language models to evaluate large language models, right? It works, to be honest. And this is the quickest way to evaluate like any incremental changes that you make to your pipeline. But having said that, you really need to think about it carefully, okay? Right. Maybe I can take a pause and see if there's any question I can take, and then we'll go into some really meaty stuff. Diana, should I start taking questions, or should I carry on with the slide and maybe I can take that at the end?
We can just continue and take questions at the end, but we'll send out a link to vote on questions.
Awesome, great. Yeah, let's carry on then. So we talked about the changing world. We talked about this LLM space. We talked about how LLM created this whole field of prompt engineering and why prompting is important. We covered traditional evaluation and how the LLM system evaluation is different than the traditional evaluation. We also thought about evaluating a system with that 2x2 axis. And we thought about few like top level ideas of evaluating. But let's talk about evaluating in practice, right? Yeah. So in my opinion, in practice, we have 3 ways of evaluating an LLM system. Or one can say that this is a more practical workflow for evaluating any LLM system. So number 1 is eyeballing, right? We start building LLM-based system. We usually start our evaluation by eyeballing on few samples or few running examples. So we have like 3 or 4 examples. We build the system on like around those 3-4 examples in order to solve those examples. And while doing so, we are literally using our eyes to see if the responses that have been generated or the chunks or the documents or chunks that's been retrieved by the retriever, they are good or not, right? And we try different components and we try different prompt templates. So the fact that we are trying a lot of prompt templates, and we might be using frameworks like LangChain and Llama Index. At this point, I will just say that, and like biased opinion, that you should try RANDB tracers. It's a great tool, and Carrie touched upon that as well. So if you're using LangChain or Llama Index, you can literally add in like 2 or 3 lines of extra code to your script, and you can start tracking the trace timeline, the input responses, the LLM calls, etc. And actually, let me quickly show tracers in action. If you can see the screen, this is a trace timeline or a trace table. So I can see the timestamp when this particular input was added, and then there was no response. So the chain basically threw a value error. In this case, the question is, what is the sign of 0.47 radian? And we got some output. But what's even interesting is that we can look through the sequence of events that happened to come to that decision. So there were some tools used, as in like a calculator was used. So let's see this example here, which is working. So A lot of LLM chains were called, calculators were called, and calls are made to the OpenAI model. We can literally look at the prompt. So what was going in the LLM, and the prompt has both the like user prompt, the instructions, the context. We can see the generation that was done. We can also look at the parameters like for this particular generation, GPT 3.5 Turbo was used, and a temperature 0 was used. So everything has been tracked, and literally it was just 2 lines of code that was added to the script. So you can start you can literally debug your pipeline with this, because you have access to so much more information that you might miss out if you're just like using the framework as it is, right? So going back to the presentation, the next way of evaluating, again, this is not the next exact step that we should do after eyeballing, but I just want to cover this before I jump into LLM, evaluating LLM, right? So this is a recommended way, because this is going to give you the most trustworthy evaluation of your pipeline, but it's expensive and slow, as I mentioned earlier. Yeah, but here's a very simple example that I tried. So the idea was that I will build an LLM-based calculator. So you give an expression to the calculator, and the calculator is going to use the BODMAS rule. It's also called PENDMAS rule, and it will generate the answer for that mathematical expression. So for your problem statement, you might have a problem statement wherein you're generating code. So you can throw that generated code to a computer to execute or compile the code, right? So that's also a form of a supervision that you can provide to the generation that you're doing, and you can use that to evaluate. So again, like if you might have, you might be generating structured SQL, you can run those SQL and see if it's giving good correct results or not. So supervision can be achieved in clever ways. In some scenarios, you don't necessarily need to hire annotators, but yeah. Now, if you have such an example, what I did was just to simulate hiring an annotator and building a data set, I came up with the expressions myself and then computed the values for all the expressions. And then asked GPT-4 with the given prompt template. So the prompt template was the following is a mathematical expression, find the answer using BODMAS rule, right? And provided the question and the formatted instructions, right? So the model was evaluated on 106 samples that I generated. The evaluation result, along with prompt usage and the cost, were all logged to WAN-DB tables, as you can see in the screen. And with the WAN-DB tables, I was able to find out all the examples for which the model was failing. So in this case, the example 19th, the true value should be 35, but the model GPT-4 is giving 25%. What's to my surprise, the model gave only 59% accuracy. So GPT-4 model, which was not able to do basic BODMAS arithmetic, but doing the evaluation on those 106 examples costed just $1. So it's very cheap, and which is the point I mentioned earlier as well. Also, the evaluation cost is going to be really negligible compared to the dataset creation cost. Even if I created those 106 expressions and evaluated them, it took me maybe 30 minutes to an hour to build that, right? While the evaluation took just a few seconds. Great. Just want to take a quick detour to emphasize the importance of tracking with WAN-DB, because when I was preparing this slide deck, I was not able to recall which model was used for that particular evaluation job, which gave that 59% accuracy in the previous slide. So if I switch to the tab, this is basically the workspace where I log everything. So there are like 134 experiments that I did, and this was calculator, I guess. So I can search that particular run, go to that run page, and go to the overview page, and in the configuration, because I logged the config parameters, I can see that, yeah, GPT-4 was used. And again, I didn't recall while I was building a slide. So I actually did this step to find. Also, I demoed WAN-DB Tracer previously. So let's go to a generation here. So for this example, 5 plus 8 into 2 to the power 3, it gave some answer. So let's see which model was used. So if I go to the LLM here, I can see that, yeah, it's GPT-4 that was used under the hood. So again, I was not logging this information, but this information was, tracked automatically by using those 2 lines of code. Great, let's come back to the presentation. Great. So at this point, for the supervised setting that I'm talking about, we have both the data set and we have the metric. So we can optimize the prompt parameters to find the best set of prompt parameters, like which LLM model is going to be best, what's the temperature of the LLM model, the prompt template, etc. Right? So in traditional deep learning, we used to do hyperparameter optimization with a tool like 1DB sweeps. If you have tried that, well, we can do the same sweep for prompt parameter optimization. Just set up a YAML file, define your parameter space as in the prompt template, the temperature, the LLM model, and then, yeah, once you have that, run the job for say 50 or 100 experiments. And once you have that, right, you are gonna get a parallel coordinate plot like this. And let me actually show this live here to all of you, if you can see the screen. So there were like 50 experiments that I did, different prompt templates, different models. So the text DaVinci 003, GPT-4, Turbo. And if I wanna pick the system, like this this calculator system, to give the best accuracy, I will have to use the GPT-4 model with this prompt template 3. So I can look at the config here. But this is gonna cost me some $2. So if I'm evaluating 106 samples, it's costing me $2. It's like negligible, but still it's costing more. The point is, if you wanna optimize for the cost and the accuracy, there's always gonna be a trade-off, right? So if you're okay for your system, maybe you're okay with an accuracy in the range of 60 plus, you can literally get away with like $1, right? So again, you're using GPT-4, but you're only spending $1 with a maybe not so heavy prompting technique, and yeah, you're okay with this accuracy. So if you run a prompt parameter optimization sweep like this, you can do this multi-objective comparison and like find out the trade-off and pick a model or a system that works best. So in this case, if I want to pick this, yeah, I will look at the configuration for need sweep 19 experiment and just pick that and use that and like deploy that maybe if I want to deploy that. So that's optimization. Great. Now so that was everything about supervision. We talked about eyeballing and how it was important and how it is important, and we talked about supervision. Now the fun part is how we're gonna use LLMs to evaluate LLMs, given it's the fastest way to evaluate your pipelines in simply. Right. So just to make things a bit more complicated, let's take an example of a Retrieval Augmented Generation or a RAG pipeline. So for those of you who is not familiar with this, it's basically a way to bring your own private data to an LLM. So you take your like document, chunk it, embed it, and create a vector store. When you are querying, you can then embed the query, retrieve the most relevant chunks from the vector store, and pass the query as well as those retrieved chunks to LLM to synthesize a response, right? So there are so many elements that's going on, and probably in your use case, it might be even more complicated than this, right? You might have multiple retrievers, and you might be routing the query from to multiple retrievers. You might have like concept of agents as well. So now, if we imagine evaluating a RAG pipeline for, say, a question answering bot over a document, we can maybe evaluate 3 important bits here. So number 1 is going to be how factually correct the response is. The 2 is how good the retrieved chunks are. So if the chunks that's been retrieved by the retriever is not good, we are not providing good context to the LLM. So the response is not going to be good. So we need to evaluate that as well. And when you are actually taking the document and chunking it into smaller text, you also need to evaluate which chunk size is going to work well for you, right? So, but before that, we need to think about the evaluation data. Again, you can hire annotators and build the evaluation data. Great. But again, that's going to take time. So we can leverage large language model here to generate the data for us. In this particular example, I use GPT 3.5 Turbo to generate the question answer pairs. How did I do that? Well, if you're using LangChain, you can literally generate with 3 lines of code using this QA generation chain. But under the hood, this chain is nothing. This chain is just calling LLM with this particular prompt. So in this prompt, it has some instructions like you are a smart assistant to come up with meaningful QA pairs, and the pair should be the point and the answer as detailed as possible, right? So the prompt takes in the chunk of text that you provide from which you want to retrieve that question and answer pair, and yeah, the LLM will do that for you. Great. Now, let's think about the metrics. So you have the question or the query, you pass it to the bot, you get an answer. And you also have a ground truth answer, which was generated using an LLM itself, right? So we can either use LLM as a metric itself. So you ask an LLM, provide both the ground truth answer and the predicted answer, and ask if it's correct or not. Or you can grade in the scale of 1 to 5 or 1 to 10. Or you can throw in a standard metric like F1 score, blue, etc. So the standard benchmarks that we use, we can also throw it here because we have access to both the ground truth answer and the generated answer. I mean, now one can say, how can you be sure that the ground truth or the LLM generated ground truth answer is accurate? I mean, now that's where the iterative cycle comes in. You need to get in the weeds, maybe look through some examples, have some more interesting way of generating the question answer pair, but this is me just giving one idea. So why LLM can be used as a metric? So it has good understanding of semantics of the test. That's something we all can agree on, right? So we can leverage it to compare the ground truth with the generated response, and it's like, and in many cases, it's going to be better than the traditional metrics like F1 or blue, right? And this is like a 1DB table wherein I logged both the question answer and the prediction and the evaluation. But if you look at one highlighted box here, you can see that for that given particular question about what is the four broad families of self-supervised learning, the model response was kind of fuzzy, while the ground truth answer was really solid and was coming from the bullet points that was in the PDF, the archive PDF file. And thus, GPT-4 said that, no, this is not the correct answer. So you can do this for an evaluation. Right. So if we are using LangChain, we can again do this in 3 lines of code. You have something called QA eval chain. So with the QA eval chain, you can just pass in the pair, the prediction, everything, and it will just give you a response, correct or incorrect. You can also change the prompt template to give it like a grade 1 to 5 or 1 to 10. Awesome. Again, under the hood is just a simple prompt, and you can modify the prompt as per your use case. Awesome. Let's talk about some standard metrics. Since we have the ground truth and prediction, we can use something like a squad metric, which computes the exact match and F1 score. For those who are not familiar, exact match is if the tokens of the model's prediction exactly matches that of the true answer, while F1 metric is basically precision and recall of the system. So precision in this case would be ratio of the tokens that's been shared between the ground truth and the prediction divided by the total number of tokens in the prediction. And likewise, recall is shared tokens by number of tokens in the ground truth. Again, fancy metric, you can use the metric as per your use case. And again, like if you're using something like 1DB tables and logging into it, you can actually see for all the data points, the individual metric as well, and not just the mean metric. By the way, I also, for this particular use case, I use Hugging Face Evaluate because it has a lot of traditional metrics, which we can literally load with just 2 or 3 lines of code. Great. Again, I will not go into the hyperparameter optimization job that I did for this, but the reason I'm throwing it here is to share a very important insight that I found from this experiment. So basically, if the evaluation dataset was created with GPT 3.5 turbo model, the GPT 3.5 turbo model gives better responses as per this evaluation metric, right? So you can see that for GPT 3.5, the mean F1 score is 51, while for GPT-4, which is a superior model on public benchmarks, is giving a score of 47, mean F1 score of 47. So, and also I will come upon this point later on because this was something which was also proved in the G-Eval paper by the authors of the paper. But yeah, let's moving forward. So far, we were able to evaluate the responses using the LLM as a metric or using some standard metric. Now, how about evaluating retrievers? So we can then, we can just save the chunks that were used to create the QA pairs. And while we are retrieving, we can basically do some sort of re-ranking wherein you take the chunk, you rank it with the retrieve chunks and see what's the rank you're getting. In this case, say if the 3 retrieve chunks are cat in, catty, cats, and the source chunk or the true chunk was cats, the rank is 1/3. And you can create, do this reciprocal ranking and then, get a mean rankings. And the objective would be to improve the mean reciprocal ranking. And again, you can use a prompt template like this when please tell if this given piece of information is relevant. And you can provide some few short examples, and then you can use an LLM to evaluate a retrieval as well. Great. So that was some ideas on how you can evaluate a retriever. How about evaluating the chunk size? So, and this is an idea that was proposed by Jerry, who is founder of Llama Index, in a tweet. So the idea is that you build separate retrievers for each chunk size. So you can have chunk size 128, and you can build a retriever for that. For a chunk size 512, you build another retriever. And during query time, you route the same queries to all the retrievers parallelly, so you don't take the extra overhead time. And then you pull all the retrieve chunks from all the retrievers, pass it to a re-ranker, and allow the re-ranker to rank all the chunks. Right, so once you have all the chunks ranked, you can then compute the mean reciprocal ranking, which I showed previously. And since every node that you are ranking is subset of that, of a retriever, you can basically say that, great, for retriever 1 with a chunk size of 128, I am getting a better mean reciprocal ranking. So let's use the chunk size 128. And that way you might be able to evaluate your chunk size. Or if not evaluate, you can use a better chunk size that's improving the performance of your model. Great. I guess just have 2 or 3 more slides and then I will be done. So I talked about LLM as a metric. So LLM can be used as a metric for evaluating chunks, evaluating retrievers, responses, whatnot. But we need good metrics as well. So one such method is this semantic answer similarity score, or SAS. So if you look at the table here, this was evaluated on squad benchmark. So a lot of metrics were used to evaluate the squad benchmark, and also humans were also hired to evaluate the benchmark. So there are 2 numbers, R and tau. So these values are basically Pearson and Kendall. They are basically correlations, and the correlation was done between the gold standard true answer that's in the benchmark with the answer that was generated by a system. And you can see that metrics like Blue and F1 score or Rouge, they are not even close to the correlation that a human annotator is getting on that benchmark. So, I mean, a SAS-based model is able to get such a system, a better or a closer correlation compared to a human annotator. we need to have metrics that are more close to human annotators. And in some cases, you might be able to find metrics that even surpass human annotators. And this task is very simple. It's just a cross-encoder model. You pass in 2 sentences with a separation token, and you get a score from a classification head. So if the score is 0.9, the both sentences are very similar. And this is 0.1, they are not that similar. And you can get an idea of how good the generation is based on that. Yeah, finally, we'll touch upon this GEval paper. So the idea here is that you specify some task introduction. So introduce the task to in a prompt or as a text. Then you also define the evaluation criteria. So how you want to evaluate. Do you want to grade in a scale of 1 to 5? Specify that. And you provide both things to an LLM and ask an LLM to come up with chain of thoughts, basically asking LLM how, if given this task and given this criteria, what are the steps that I should take to evaluate? So it's like auto chain of thoughts, right? And you take all of these things along with the input context and the target generation, give it to an LLM, and it can generate a score for you. And hurrah, you have a better metric here. Again, you can read the paper, it's really good. And they also have an open source repository, which you can try. But I really want to stress upon a few of the points that the authors of the paper came up with. The number one point is that they said that GPT-4 is a very strong evaluator, so we can use it. But if we use some chain of thoughts and some fancy output tricks, we can literally use this as a good evaluator. If we are asking an LLM to evaluate or grade in a scale of 1 to 5, make sure that, rather like sometimes the LLM will have a dominant generation. So in a scale of 1 to 5, it will dominantly generate 3. In a scale of 1 to 10, it will dominantly generate 7, which is not good. So maybe you can ask the LLM to generate text, so correct or incorrect, like that. Also, if you're asking LLMs to generate decimal value, so 2.3, 1.7, like this, LLMs have the tendency to like generate integers, which is, again, it just kills the granularity of your evaluation. So you want decimal values, but so you have to be thoughtful of these things. And when you're evaluating, you just cannot blindly throw in an LLM. You need to do this analysis as well. And finally, the point that they concluded with was that GPT-based evaluator has a bias towards GPT output. And this is exactly the same thing that I showed previously from my hyperparameter prompt parameter optimization job that I showed, where the GPT 3.5 Turbo was performing better on the question generated by GPT 3.5. So again, you need to be thoughtful of what model you are using to build a pipeline and what model you are using to evaluate the pipeline. Right. Again, I mean, I think I am, yeah, I mean, it's almost time. And if anything was not clear, feel free to reach out to me. But these are the main takeaway points that you should consider. And finally, it was a lot that I kind of tried to cover, but I highly recommend trying out this Evaluating and Debugging Generative AI course launched on deeplearning.ai in partnership with OneDB. Carrie was the amazing instructor who walked us through that course. And yeah, again, feel free to reach out to me on any platform that you feel like to ask more questions. Having said that, I am mostly done. Yeah, we can then, I guess we can take questions.
Amazing. Thank you so much, Ayush. I'm also going to bring back up Morgan so we can answer some questions from the audience. I hope this was very helpful for a lot of people watching. We only have time to go through a few questions. We will drop the resources in the chat and the slides, and we'll also drop a survey as well so that we can improve the event experience and all the education we want to bring to everyone. But to start off with, for our first question, why don't we start with, how do you come up with good data sets to assess the LLM performance?
Yeah, I mean, the answer, to be honest, depends. Again, if you're building an LLM-based system, the good data set is something that you need to come up yourself, or you have to be clever about that. If you're building an LLM or a large language model, there are really good benchmarks out there that you can try. Helm is a good one. if I recall correctly. There are a few more as well. Big Bench is a good one. So you can use those to assess your LLM performance. But for your own application, you need to be thoughtful about how you're building those data sets.
Absolutely. Perfect. Let's move on to, do you know any domain-specific LLMs, such as legal? Wondering what are the best practices to train these types of LLMs, build one from scratch, or adapt existing LLMs?
Morgan, you want to take that? Or I can.
Sure, yeah. I haven't heard any domain-specific legal ones recently, not in this like current crop of, like multi-billion parameter. There's been like other NLP models before, like on the smaller scale, that have been fine-tuned on particular legal data sets. I'd say if you go to the Hugging Face Hub and maybe just like search legal or law or lawyer, you might find something. In terms of like best practices, definitely adapt an existing one. You want to rely on like the incredible amount of like capability in like a Llama 2 model. So you'd just fine tune that. If there's a particular set of like law in your like country or just jurisdiction or type of law, just try gather all that data, parse it, clean it, and then fine tune an existing powerful foundation model.
Awesome. Perfect. Why don't we dive into what are the drawbacks to allowing the LLM to evaluate completions?
The drawbacks can be multifold. Again, as I said, that say if you are building an LLM system and using Claude model or a Cohere model, and you are trying a GPT-4 to evaluate that, might be GPT-4 will not do a good job at evaluating those systems. So you might have to try out a bigger Claude model for that. Also, many a times, for example, like I showed in a slide that as you scale, LLMs unlock abilities, but that doesn't mean LLMs will unlock abilities to perform really well on legal use cases or a medical use case. Maybe you need to fine tune an LLM for your use case and then try to use that as an evaluator. So there are drawbacks. You need to be thorough about it, to be honest. Morgan, do you want to add anything to that? Or is it good?
No, yeah, it's still early days. The jury's kind of out on how effective they can be. They can, with a bit of work, they can be directionally correct. So it mightn't like get every one matching a human annotation, but you can maybe broadly know if your generations are going in the right direction.
Yeah. Personally, I tried Cohere and saw GPT-4 not evaluating it well, and vice versa. So yeah, we need to be thoughtful about it.
Absolutely. Perfect. Well, I think this ends our time for our workshop and event today. Thank you everyone for attending, and thank you the Weights and Biases team, not only for working with us on our course that you're able to take, but also for this amazing workshop today. I'm sure we'll do many more in the future. We have dropped a link for the survey in the chat. So if you could please fill that out, definitely helps us decide what will our next topic be for the next event. And thank you, Ayush, Morgan, and Carrie for coming out today. We'll see you guys next time.
Thanks, everyone.
Thanks, everyone.
Thank you.